Alright, so if you'll remember, complex numbers have the imaginary number I in them. So A and B would be a regular number, I is your imaginary number, and if you don't remember, I is the same thing as the square root of -1. That's the definition of I, because we can't square root negatives, right, and come up with an answer. I can't square root like a -4 and come up with a number that multiplies by itself to make -4, because anytime you take something times itself, it always comes out to be positive. So the complex numbers are written as a number plus a number times I, or a number minus a number times I. So when I add two complex numbers together, I literally just add the same spots. So if I take the 3 and I add that to the 2, that gives me 5. And then I've got -I plus 3I, that would be positive 2I, and there's my answer. Alright, same thing when you subtract. I would say 1 minus 4, that would give me -3, and 2I minus 2I would give me 0, so that would just be -3. If I add 3 of them together, or subtract whatever, I just do them in order. So I've got 3 plus 4, that would make 7, minus 7 would give me 0, so I don't have a number out in the front. Then I've got 2I plus a -1I, that would be I, minus I gives me 0, so this is just 0. And if you wanted, you could do the first two and then do the last one. I just kind of like to hop and do each spot all together. Now, let's say that you wanted to make sure you were correct. You can plug these in the calculator, and you do that by, you got a parenthesis, so parenthesis 3 minus, and then I is right down here at the bottom above the decimal, so I would press second and the I right there. Do I know I'm not even on the right screen? Okay, I am on the right screen. Alright, so I've got, I think I cleared that out, 3 minus I, close that up, plus, open 1, 2, plus 3, I, and that gives you the 5 plus 2I, which is what we have right here. Alright, when you multiply, you still do them just like you would any other binomial. So I take the 2 times the 4, that gives me 8. And 2 times 3I, that gives me 6I. Then you've got -I times 4. -I times 4 is -4I. And then -I times positive 3I would be a -3I squared. And if you'll recall from Algebra 2, I squared is the same thing as -1. So I can replace that with -1. So I've got 8 plus 6I minus 4I. And if I replace this with a -1, that would be -3 times -1, which would give me a positive 3. Then I can just add like terms. Remember, I want the I to be at the back, so I'm going to do 8 and 3 first. That gives me 11. And then 6I minus 4I is 2I. And again, to check yourself, just plug this in just as it looks. Now when I square, remember you can't just take the first number and square it and the second number and square it. This is this times itself twice. So you would actually be doing 3 plus 2i times 3 plus 2i, and then you're going to have to FOIL that. So I have 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is 6i. And 2i times 2i is 4i squared. I always replace the I squared with a negative 1. So this is going to be 4 times negative 1 at the back. So I have 9 plus 6i plus 6i, and then 4 times negative 1 would be negative 4. So put your numbers together. You have 9 and negative 4. That's going to give you 5. And then 6i and 6i make 12i. And again, I could just plug that in as it looks up here, and it will give me the answer to that. All right, when you're dividing, you have to worry about your conjugate. All right, so things I don't like in the denominator of fractions would be like a negative integer. I don't like fractions down there. I don't like square roots down there. So I don't like an I down there either. So that's where the complex conjugate comes in. And if you'll remember, you just change the sign that's in front of the I. So if it was positive, now you're going to have a negative. And what that's going to do is it's going to cancel out your middle terms so that you don't have an I anymore. So I look at the bottom and I say, okay, I don't like that I have an I down here. So I'm going to multiply by the conjugate of that bottom, which would be 4 plus 2i. And I have to do that on the top and on the bottom. So I'm going to have all of this times that and all of this times that. So I'm going to have to FOIL twice. So I have 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. Then I do the bottom. 4 times 4 is 16. 4 times 2i is 8i. Negative 2i times 4 is negative 8i. And negative 2i times positive 2i is negative 4i squared. So you need to take care of your I squareds back there. Now, essentially, all it's going to do is change the sign of this, right? If this is negative 1, it just changes the sign of this. So that would give me 8 plus 4i plus 12i minus 6. Same thing on the bottom. 16 plus 8i minus 8i plus 4. So you're literally just going to change this back number's sign. Okay, now on the bottom, these should always be the opposite. So same number, different sign. Because that's what the conjugate did for me. It makes the outside and the inside terms that you multiplied opposites. That way they can cancel and you won't have an I left. So on the top, just combine your like terms. 8 and negative 6 give you 2. And 4i and 12i give you 16i. On the bottom, these two will cancel, and 16 and 4 give you 20. Now, when we write a number, we should have two terms, right? We should have a number and then plus another number that has an I. So this would be 2 over 20 plus, and then 16 over 20 times I. Essentially, I'm just taking this one and dividing by 20 and this one and dividing by 20. Then you just need to reduce, so 2 over 20 reduces to 1 over 10. And 16 over 20 reduces to 4 over 5 times the I. Now, I think both of you have the newest calculator. If you get yourself a fraction, right, and in the top we should have 2 plus 3i. And in the bottom we have 4 minus 2i. And that's exactly what we got, correct? Now, if at any point you have the calculator that's thicker, just the TI-84 plus C, not the plus CE, the skinny ones, it won't let you do this. So what you have to do is put a parenthesis and then do the 2 plus 3i, so in other words, there's the top, right, divided by everything on the bottom, but you have to put it in parentheses to show that, hey, this is everything in the bottom. And then it's going to give you like this decimal, and then you would change that to a fraction. So math, enter, and then you get that. So it's kind of like you got to do a little more work just to get to the answer. So it's still doable, you just kind of have to work around the programming in the calculators. All right. So if I wanted to work this one out, I'm going to look at the bottom, and I see that I have an I, and that's unacceptable. So I'm going to multiply by the conjugate, which would be 2 plus I. So I'm going to do that on top. And I'm going to do that on bottom. So I have all of this times the bottom, all of this times it. So 2 times 2 is 4. 2 times I is 2i. I times 2 is 2i. And this is going to be I times I, which is I squared. So in front of this is just a positive 1, so that's just going to change this to negative 1, so we'll change that in a minute. Then the bottom, 2 times 2 is 4. 2 times I, 2i. Negative I times 2 is negative 2i. And then negative I times positive I is negative I squared. So this is negative 1. So that's going to change this positive 1 to a negative. So I have 4 plus 2i plus 2i minus 1. And it's going to change this negative 1 right here to a positive. So 4 plus 2i minus 2i plus 1. So I'm going to combine my terms. 4 and negative 1 make 3. 2i and 2i make 4i. 4 and 1 make 5, and these two cancel. Then I'm going to split this off into two separate terms. So I have 3/5, that does not reduce, plus 4/5, that does not reduce, times I. And again, you can check yourself by plugging into the calculator. I do want to point this out, though, because when you multiply two binomials that are the same, like this is a 2 plus I and a 2 plus I, you multiply your fronts, that's 4, right? And then the middle is always doubled. So if it's 2i and 2i, it's going to be 4i. So if you multiply 1, then you should just double that. And that's actually something short that would be good for like a test prep kind of thing. All right. When you multiply square roots, okay, multiply what's underneath them. So I've got negative 3 times negative 12, which is going to give me a positive 36. And then the square root of 36 is 6. All right. When you are adding or subtracting, you can't put two roots together that aren't like terms. So for instance, let's say that I have 3 square roots of 2 and 2 square roots of 2. I can add those together, and I treat this kind of like a variable. All right, if I had like 3a and 2a, that would be 5a. So this would be 5 square roots of 2, right? Treat it like an object. Like I have 3 of these and 2 of these, so now I have 5 of these. So this root at the back has to be the same. Like, so I couldn't put these together. But I also realized that, number one, they have negatives underneath, and I need to take care of that. Number two, they are not simplified. So we need to simplify them first. The first thing I realized, though, if I square root a negative, I know I'm going to have an I. So I'm going to go ahead and split this off into 3 roots. One of them is going to be -1. I'm going to put that one at the back. And then 48. I need to come up with 2 things that multiply to make 48. One of them needs to be a perfect square, and the other one needs to be a prime number or the product of 2 prime numbers. It's 16 and 3. 16 is a perfect square, and 3 is a prime number. But there's a way to get to that without, trying to guess. If you do a factor tree, 48, so that would be 2 times 24. 2 is prime. 24 is 2 times 12. 2 is prime. 12 is 2 times 6. 6 is prime. 6 is 2 times 3, and both of those are prime. So if I wrote this, it would be 1, 2, 3, 4. So I have 4 of the 2's, and then I have a 3, right? And if you square root that, 2 to the 4th is 16, right? And remember there's a little 2 out here. So to simplify this root, I would take the 4 and divide it by the 2, which would give me 2 to the 2nd, which is 4, right? So I end up with 4 square roots of 3. The square root of 16 is 4. The square root of -1 is I. And then you've got your square root of 3. I don't like the I at the back. Make sure you put it in front of this root right here. Okay, so that's like the behind-the-scenes math work, right? I always just go with a perfect square and a prime number, or the number that's the product of 2 prime numbers. Also, the little calculator will do that for you. So you have square root of 48. And it tells you it's 4 square roots of 3, and then you know that you have an I in there with it, so you can stick the I with it. But don't put the negative in there. This calculator doesn't know what to do with that, okay? So you just need to recognize that if you have a negative underneath, that you're going to end up with an I. All right, so I've got 4i squared roots of 3. So if we take that, and let's just say we do it in the calculator, okay? I've got minus. If I take, I already know I'm going to have an I, right, because I have this negative underneath. So if I take the calculator and say square root of 27, I get 3 square roots of 3. So that would be 3i square roots of 3. See how this back behind that coefficient in the front is the same? So I have 4 minus 3. That would just give me 1 I square root of 3. And also, I think if you took out the negatives and you did square root of 48 minus square root of 27, you would get square root of 3, right? And then you can just tack on your I square roots of 3. All right, when I'm multiplying, because that's what this is, when I am multiplying, this is this binomial squared. So I'm going to take negative 1 plus the square root of negative 3 times negative 1 plus the square root of 3. Oh, negative 3, sorry. Now, I don't want that negative in there when I start multiplying. So, instead of saying the square root of negative 3, I already know that's going to be an I. So I'm going to say I square roots of 3, negative 1 plus I square roots of 3. And anytime you have an I, you would have to use the bigger calculator. And it's not going to give that to you in a format that you want. It's going to give it to you in decimals, and it won't put a root where it needs to be. So you have to do them by hand. So I have negative 1 times negative 1 is positive 1. And then negative 1 times I square root of 3, that would be negative I square roots of 3. And then I have another I square root of 3 times negative 1. So negative I square roots of 3. And then you have to be careful back here. Make sure you do the outsides and your root. So I times I gives you I squared. And then when you take a square root times itself, like square root of 3 times the square root of 3 would be the square root of 9, which is 3. But we never write it like that, right? This is 3i squared. And then what's going to happen to this positive 3? It's going to change to a negative 3 because this is a negative 1. So negative 1 times 3 is negative 3. Then you're going to put these together. So 1 and negative 3, that gives you negative 2. And then I have a negative I square root of 3 and another negative I square root of 3. So that gives me negative 2 I square roots of 3. Alright, so when we solve for this, I can't factor this because, well, one, I would have to have a perfect square, and a minus to have the difference of two squares, or I would have to have a trinomial that I could factor, and I don't have either of those. But I do just have this x squared, so I can solve for that. So I'll subtract the 4. So I get x squared is equal to negative 4. And then to get rid of my squared, I have to square root, and I don't want to forget the plus or minus. So if I take the square root of a negative, I know that I'm going to have an I. So all that's left is the square root of 4, which would be 2. So I just get plus or minus 2i. Alright, on number 12, let's say I wanted to try and factor this. I'd take the 3 times the 5, which would give me 15. So the only thing that multiplies to make 15 is 5 and 3 and 15 and 1, and neither of those add to make 2, which means I'm going to have to do the quadratic formula since I have a quadratic. So remember, the a is the number in the front of your x squared, b is the number in front of the x, and then your c is the number that doesn't have a variable. So you've got x is equal to, and then I always think opposite of b, so 2 plus or minus the square root b squared, and it's really important that you put parentheses since b is negative, minus 4 times a times c all over 2 times a. So remember, when we do these, we want to make sure that we get what's underneath the root first. Alright, which would be 4 minus 4 times 3 times 5, negative 56. All over 6. So you need to reduce this root right here. So if you want, you already know that since you're rooting a negative, you're going to have an I. So if you get your small calculator and you square root 56, you get 2 square roots of 14. for the square root of 56, and then you're going to just tack on your I with that 2, so 2I square roots of 14 all over 6. And if you'll notice, all 3 of these terms will divide by 2. So that would give me 1 plus or minus 1I square root of 14. Don't reduce the 14, it's under the root, all over 3. And since this is a plus and minus and it's not just like 1 plus I square roots of 14 over 3, we won't split it up into 2.